This is the experiment on determination of breakdown strength of solid insulating material. The objectives are to acquainted with standard code of practices for determination of breakdown strength of solid insulating materials, to determine breakdown strength of 0.15 mm thick capped paper, 0.8 mm thick pressboard, 0.3 mm thick leatherized paper, 0.2 mm thick mica sheet, 0.3 mm thick polythene sheet. This is the experiment on study of different types of insulators and underground cables. The objectives are to know about different types of insulator and their used, to know about different types of cables, installation practices and uses in different voltage gradation. Some different types of insulators are pin type insulator, suspension type insulator, strain insulator and cycle insulator.
Here we see the kit for dielectric strength test on insulating oil, and the objectives are to learn about the various properties of insulating oil for transformers and switch gears, and to carry out dielectric strength on a sample oil of according to IS 6702 of 1972. Now this is the kit of a transmission line simulator from which we can determine the generalized constants A, B and C, D of a long transmission line. And from this experiment, we can measure the voltage and currents at two ends of an equivalent long transmission line under open circuit and short circuit conditions, and to realize the Ferranti effect in the system from the value of sending end voltage and receiving end voltage, and to compute A, B, C, D parameters of the transmission line from the obtained data. This is a network analyzer for simulation of DC distribution network, and from this we will verify and calculate potential differences at each node point and current flow in each section of distributor. When the distributor is fed at one end, the distributor is connected as a ring, the distributor is fed at both ends.
Taking the voltage between mass and fundamental voltage. And the frequency, we have already adjusted the voltage mass voltage and alternative mass voltage is equal. When these two frequencies will match, it is to 0, and when it is out of phase, it is also maximum. You can visualize it. When it will be 0, the frequency is green. When it is out of phase, it is red. And now, by this, you can adjust the speed. Now, you can visualize it more accurately. When it will come 0, then it will zero, it is same page. It will be extreme out of phase. Now it is in the same page. Now when it will be in the same page and the synchronization indication will come, I will synchronize it like this, just synchronize it. This is synchronization lamp. So the alternator is synchronized with the bus bar.
The experiment is on linear system simulation using hardware kit. The objective is to study the time response of defined simulated linear system. The apparatus used linear system trainer kit and CRO. All blocks in the system have a transfer function with 180 phase shift. It works as error detector cum gain, integrator, time constant, disturbance adder and uncommitted amplifier. The experiment is on study of PID controller using hardware kit. The objective is to study of the performance characteristics of an analog PID controller using simulated system. From this experiment, we can find rise time, peak time, steady state value, steady state error, etc. So this experiment is very essential in the field of control system in industrial aspect.
We want to take means closed loop transfer function we are taking here, right? This is the gain. Here we have given step input. Coming to the summer block, from summer block it is going to gain. Then we have connected here. This is the plant, from plant this is the feedback. So here we are taking CRO from X channel, we are taking the input of the CRO and we are taking the output here in this Y channel, we are seeing the output. So this is our waveform. We can see this is an underdamped waveform we are getting. Now we have to take the reading in terms of time and response we will take this. Okay.
This is the instrument of AC coil winding design. AC winding design can be of concentrated winding and distributed winding, and mainly for 3-phase induction motor we choose open windings. As per requirement, coil designing can be done for 4, 6, 8 poles also. Maximum speed range of 1500 rpm with 36 coil slot in stator. Now this is the experiment of load test on a single phase induction motor and deriving its performance characteristics. The objective is to run the machine at no load and then to load it for necessary data which may be analyzed to get torque and output power and efficiency also. The theory is based on torque developed in a single phase induction motor field so produced by one winding is pulsating. Naturally, average torque developed is 0. Forward torque of forward field cancels out due to reverse torque to backward field is much less if speed somewhat raised to near synchronous. Thus, single phase induction motor can run by itself if problem of starting torque is solved.
This experiment on speed control of 3-phase squirrel cage induction motor by different methods and their comparison. The objective is experimental study of starting and running features with different starting methods for 3-phase squirrel cage induction motor. Two type of control is there. One is stator voltage control. Developed torque in case of induction motor is proportional to the square of terminal voltage at a constant value of supply, and other is variable voltage of frequency control. and changing the supply frequency, the speed of the motor can be controlled.
In the case of no load test, the motor is uncoupled from its load and the rated voltage at the rated frequency is applied to the stator to run. In the case of block rotor test, the shaft of the motor is clamped so that it cannot move and rotor winding is short circuited. Our next experiment is no load test and block rotor test, which is mainly used to determine the efficiency of 3-phase induction motor, and it is also used to determine the circuit parameters of equivalent circuit of a 3-phase induction motor. Let's move to the experiment of self-excited induction generator. An induction generator are generally of two types: self-excited, super-synchronous induction generator. In self-excited phenomenon, the generator is supplied with adequate reactive power, which is utilized to produce the desired active power. In super-synchronous mode, the machine is made to run at super-synchronous speed and it draws reactive power from the grid, supplying active power to the grid. This is the experiment of slip test on salient pole synchronous machine. The objective is to determine the direct axis reactance XD and quadrature axis reactance XQ. With the oscillation of stator current, the applied voltage also oscillates a little in reverse order between some minimum and maximum. Thus, taking advantage of slip condition, the direct axis reactance XD and quadrature axis reactance XQ as offered by the salient pole synchronous machine can be found out easily.
Induction is explained actually equivalent circuit parameter of a single phase induction single phase induction equivalent circuit parameter is motor physical thing convert into electrical circuit.